Okay, so this looks a little bit different than what you're used to. I'm trying some new things with the new year and everything. So I post it for you on Moodle, basically this blank thing. It has, spots for you to fill in what I'm going to be filling in. Hopefully it makes the notes a little bit easier for you to follow and fill in the blanks and write your example problem. So you should be writing what I'm writing, but it kind of saves you some time with certain things. So we'll see how this goes. Yeah. Okay, so we're doing 5-2, and it's dividing monomials, okay? So we're kind of thinking of monomials, it's the term, it's kind of like one term. So it says, our first we're going to do the rule of property of quotients right there. And it says, if A, B, C, and D are real numbers, and B does not equal 0, and D does not equal 0, then AC over BD equals AB times CD. Let's see, I might get a thinner pen. I don't use OneNote, and that's kind of thick. Okay, so that is the rule. That's what the property is. So you see how you can break it up to A, B, and CD, because if you were to multiply them, you just multiply across. Now this allows you to divide the numerator, which we know the numerator is the top of the fraction, and denominator, which we know that is the bottom of the fraction, denominator of a fraction, by the same non-zero number to simplify the fraction. So we're just simplifying the fraction, and this is going to help us later on when we're dividing monomials. Okay, so we have an example. So you see this? We want to simplify this right here, and we're going to do that by separating. I'm going to put the kind of the like things together. So I'm going to do the negative with the 4. So I'm going to say negative 4 over 10. So I took the numbers, separated them. Now I'm just going to separate the x's together. So I'm going to say x at the top over x, because I got that from right here. I don't know if you can see. I don't know if you can see my mouse on that. And then we have y over 1, because I have a y at the top, but nothing. I can always put it over 1, because, I can always multiply the bottom by 1. Doesn't make a difference. So now I split it up using that rule that we had, okay? And now I can simplify it a lot easier. So I'm going to simplify negative 4/10. We know, oh man, okay. Again, I'm learning with this. There we go. I just hit something. Okay, so, I don't want that. Okay. So we have negative 4 over 10, which is the same as negative 2/5. X over x. X over x is actually 1. They can't kind of cancel each other out. So I'm just going to, oh my goodness. Which that's going to be the same as 1 over 1. And then y over 1 can't reduce anymore, so I'm going to leave it like that. And now I'm going to combine them all together to simplify it at the very end, and I have a negative 2y over 5. So that's my final answer. That's what I simplified it to using that rule. Okay. Rule of exponents for division. Okay, so if we were to have a non-zero real number and m and m are positive integers, okay, so this is the kind of the case we're going to use. So we're going to say we're going to be using a raised to the m power over a to the n, and so these are our rules based on that. So if we know that m is greater than n, then we're going to have a to the m over a to the n is going to equal a to the m minus n, okay? So you're going to be subtracting the exponents, okay? That's if the higher number is at the top, okay? So you have to pay attention to this rule right here. I'm going to erase that. But you got to pay attention to that. So my example for this one, if I were to have x to the 5th over x to the 3rd, is the top one, which in this case m, bigger than the bottom one exponent? Yes. So I can use this rule. So I can think of this as, wait, not x. Oh yeah, x 5 minus 3, which is, we know is 2, so x squared. So my answer would be x squared. Now you won't have to write the 5 minus 3 every time. I'm just doing that to show you my steps. Now another way to think about this, I could write this same problem as x times x times x times x times x, right? That's the same as x to the fifth. And I can write that all over x times x times x, which is the same as x to the third. I'm going to use a different color, and I can cancel out these x's, I can cancel out this, and what am I left with? I'm left with x squared at the top. So, it's the same thing. See? That's why I get the same thing. Same problem, showing you two different ways to think about it. Okay, so if n is greater than m, so we still have this situation, we still have a to the m over a to the n, but this means the bottom exponent is bigger. So this, in this case, we're going to have 1 over a to the n minus m. So, our example, if we were to have y squared over y to the fourth. Now again, we check, y to the fourth is in the denominator, and that's the bigger number, so it works for this case right here. Okay, so I'm going to say that's the same as 1 over y, and then I'm going to say 4 minus 2, because I do n, which is the bottom one, minus m. So that gives me 1 over y squared. That's my answer. Again, another way to think about that, y times y, y times y times y times y, that is y squared over y to the fourth, and I can cancel those out, and I am left with 1 over y squared. Same thing. Lastly, pretty easy one, if m equals n, so if I were to have a to the m over a to the n, and they equal each other, then that's going to equal 1, because they're going to both cancel each other out. Another way to think of it, I haven't specifically brought this up, that's a to the 0 power. If you have something raised to the 0 power, that equals 1, okay? Always. So a always equals 1 if it's something to the 0 power. Just something to know for future reference. Again, another way, an example right here. B squared over b squared, that is 1. Again, you can also think of it as b times b over b times b, and I would be canceling these out, and that would give me 1. Okay? Some example problems. Okay, so hopefully I'm on your notes. So x to the ninth. The ninth is bigger than the bottom one, so I know that I'm going to be doing x to the 9 minus 5. Again, you don't have to necessarily write this out every time. I'm just showing y'all. Equals x to the 4th. And now, again, I'm using that first rule that we had to break it all up. So I'm going to say this can be written as 35 over 56 times x cubed over x to the 5th times y over y times z to the 6th over z. So now I'm going to start simplifying. So I know that 35 over 56 can be reduced to 5/8. And then, okay, 3 is on the top and 5 is on the bottom. So that means the bigger number's on the bottom, so I know that the top has to be 1, and I'm going to be left over with 2, so it's going to be x squared. And then, and you'll get better at it as you go along, you'll be able to recognize it. Y over y, that's 1, so 1 over 1. And then if I have z to the 6th at the top and 1 z at the bottom, that means I have more at the top, so that means it's going to be at the top, so I'm going to have z to the 5th at the top, because only 1 gets canceled out. So there we have that, and that can give us to our final answer of, I'm going to put all the top together, so 5z to the 5th over 8x squared. And finding the GCF of monomials. Do you remember what GCF means? It remains greatest common factor. And so that, so finding the greatest common factor of monomials, you get the prime factorization Okay, so, and we're going to find the prime factorization of the number, and then we're going to kind of put the variables after it. And it says use all the common factors to the smallest exponent. We kind of did a little bit of this on last video, okay? So first, I'm going to just find 72. I'm going to find the prime factorization of just 72 first. I'm going to worry about that. So I know I can split it up as 9 and 8, so that gives me 3 and 3, and 4 and 2, which is also 2 and 2. So my prime factorization is 2 to the third times 3 squared. But now I still need to account for those, so I'm going to just write them next to it. So it's going to be x to the third times y times z to the third. So that is my prime factorization for this first one. There we go. Now I need to find the prime factorization for the second one before I can get my final answer of my greatest common factor. So split that up, 12 and 10. That's going to be 3 and 4, 2 and 2, 2 and 5. So that gives me 2 to the third, 1, 2, 3, times 3, times 5, and then I need to put the stuff at the end. Okay, so we need to find with the smallest exponent. They both have to have it. Okay, so this is my second one. They both have to have it for it to be included for the GCF. So I'm trying to find the GCF. So this one on the left side, it has 2 cubed. The right side has 2 cubed. So they both have 2 3 times. So I can use that. So 2 cubed. Now on the left side, it has 3 squared. On the right side, it only has 3. So the smallest exponent is 3 to the 1, right? So we can only use 1 3 because they both have to have them in common. Now x, right on the left side they have x cubed. On the right side they have x squared. Now they both have to have the same amount, so they have to have both. We only can use x squared because both of them do not have x cubed. So the most we can use is x squared with both of them. There's a y on the left, but there's none on the right, so they don't have that in common. On the left we have z cubed. And on the right we have z to the 5th. So the most they have in common is z cubed. So I'm going to simplify this. 2 cubed is 8, so 8 times 3 is 24. X squared z cubed. So cubed. That is my answer. That is my GCF of those two monomials up there. Okay, that is my answer. Okay. I hope you liked this. Hopefully, it was easier to follow along. Okay.